means there is at least 2 elements in the coefficient list. The first element we look at is the second, so it's fine. And then return the derivative. No. Okay. Maybe we can print poly here. Print poly here. So minus 0, minus 0, plus 0. That is what we get right after allocation. 1, 1, 5. After this, then you derive, and you get this. It's not the right answer. And is equal to 2. So it's definitely not smaller or equal to 0. We don't do this. Go here. P dot n minus 1. That's 1. So we get 2 positions. Okay, so now before we initialize, we get just random noise in the position. So that's what you see over here. It's just it read some random bits as if they were a double precision. Then this is the polynomial you start with. And what would need to happen would be you get 1, and then you get 5 times 2. And you don't get that, you get 0. So maybe it's as simple as casting nope. Okay, in this case dir.n be equal to 1. Oh. Okay, let's do this. Bug, and that's what it gives you. You can try to derive twice in a row. Try to derive one more time. 0. Yeah. We do. Problem was that when n is equal to 1, the biggest value that we want to look at in the previous polynomial is going to be 2. No, 1 would be this. The biggest value is 2, so we need I plus 1. The way of doing it is you start 1, but you go to dir plus 1. Do it like this. And you get the same answer. Notice how you get different values on different runs. Okay. Another thing we can do evaluate at. So say you give me a point x and you're asking for the value of a certain polynomial at the point x. Oh, it's going to be same thing we do with the printing, actually. Let's just grab that. It's going to be the same thing we do with printing. Right. P dot n is equal to -1. Return 0. So we know that P dot n is at least 0. So P dot coef for I close to 1, I smaller or equal to P dot n I plus plus. Okay, so that's one way of doing it. Another way, if you don't want to use POW, okay, here's another way you can do this.